now, standing between you and lunch. And hopefully, I hope that it's going to be an acceptable appetizer. So, I'm also a mitochondriac, as for Dr. Ross. I've been actually passionate and very much interested by these organelles since, well, a long time ago now. And as Dr. Ross was mentioning before, is that what's fascinating for me at the level of these organelles is that not only they are powerhouses, so they provide cellular energy, but also they more and more, I mean, at least in the last decades and so, they have been shown to be more and more involved in cell signaling, in the definition of the cell physiology, cell behavior in general. So we had, for instance, Dr. Ross talking about the speciation issue. Now we think more and more that there is a need of combination between product from mitochondrial genome and the nuclear genome, and for them more specifically to click properly together in order to allow the species to be fit. So we have an ongoing collaboration that I hope is gonna, we got some promising results, and I hope that they are gonna actually keep being more than promising, let's call it this way. And but in case, as of course Dr. Ross told you about this research already, I want to focus more on the research project that I'm planning to actually here, having it host in the Jordan building, which is more related to reactive oxygen species. So here, the idea is that mitochondria are wonderful transduction machineries, which allows transduction from redox energy into chemical energy at the level of the ATP. But if the process is not properly achieved, you get electron leaks, and these electron leaks at the level of the mitochondrial level can potentially generate reactive oxygen species, and more specifically, peroxide type oxygen species. And these peroxides have been actually shown to be more and more involved in not only as toxic agents, but also as signaling agents at the level of different type of organisms. So we all know our context. Now it's been reminded and recalled to us several times. We are in a valley where the agricultural activity is pretty intense. And on top of that, all these field activities are tending to generate several compounds and contribute to a specific air pollution, which essentially can lead towards inflammation problems at the level of the population. And kind of the hypothesis that we have, and we are not the only one to have it, is that if you inhale these type of particles, you can potentially have your first cellular defense system, which can transduce this energy as signals, which can lead to inflammation. And this inflammation in most of the cellular systems are mediated by reactive oxygen species. So there are at least a burst of reactive oxygen species which happen during inflammation in order, for instance, at the macrophage level, to kill effectively the invaders inside their core. So the approach that we take is that, first of all, we have a very good and effective and ongoing collaboration with Dr. Hassan at the level of the chemistry department, who is very kindly is providing us with particles which have been collected here in the valley at the level of big pond collectors. And we actually, oops, what did I do here? Sorry, where's the pointer?
That won't show up on that screen.
Yeah. Okay, so no pointer, so finger, the good old pointer. So in order to test the the possibility or the possible contribution of these particles to the production of reactive oxygen species, we cultivate macrophages in vitro, and we actually elute the particles from the collection filters and expose these macrophages to these particles system. And what we can see is that, first of all, the cells do respond. So we can, by using a fluorescence-based system, so a probe, which is going to actually shift its fluorescence spectrum when it binds to reactive oxygen species, that we have definitely a different type of response depending on the origin from where we actually collecting the different samples. So here, for instance, it's just a comparison between samples that we collected from Fresno and from Clermont, so two different, Fresno here, Central Valley, of course, and Clermont at the level of the coastal side. And as we can observe is that basically there is a differential response. So due to this difference in specific response, there are definitely a possible issue that we are kind of mentioning here, is that here all the law system is based on limitation at the level and the control of air pollution based on the total or the measurement of the total amount of particles in the air, when in reality they do, depending on where they come from, they do not actually trigger the same type of cellular response. So sometimes you can have very low amount of particle, but still that's going to actually contribute to more issues. In my last minute, actually, I just want to talk real quick of this collaboration that we have ongoing with Dr. Bourraou. So here, he already actually presented you the ejection system. The idea is to try to actually limit the possibility of oxidative stress at the level of the roots of the plant by an irrigation of water which had been pre-enriched with air from the surface. So we had very preliminary results, as you can see at the level of the presentation here, showing that if you actually relate to the glutathione system, which is one of the main system of ROS buffer inside the cell, we can show that there is a potential effect of protection at the level of this ejection system based on the fact that you have a less pro-oxidative environment inside both plants and fruit of the crops, which were tomatoes in this case, in the system. So this is just to sum up a little bit everything, say that here the idea is to take advantage of the system at all the models to not only enrich our knowledge at the level of the agricultural science, but also at the level of the fundamental science. And hopefully, that would be my hope, be able to potentially involve the mitochondria as a main actor at the level of this type of regulation. And this is just to thank everybody who contributed and helped me at the level of this project. So I have 3 students with me here, Anthony, Kosha, and Joel, who actively worked on the ROS project with Dr. Hassan, who's there, actually, and also this project with Dave Bourraou. And also thank you very much to Florence to have had us introduced at the level of this building and everyone. Thank you very much for your attention.